Okay guys, we're going to do a very quick summary review of last time, and we're going to talk about new materials today. Last time we talked about some of the terminologies for stat study that we'll be using, and how do we try to differentiate different types of data. First of all, we talk about populations versus sample. We know populations includes everything that's being studied, while samples is just a subgroup of populations. And we used a Venn diagram last time to show populations versus sample. And data can be classified as qualitative or categorical. So data can be kind of qualitative, or the same as categorical or quantitative, right? And we can also use 4 basic types of measurements for data. Those are nominal, ordinal, interval, and ratio. And I think we emphasize that for ratio, it has meaningful 0. While interval has no meaningful 0. And nominal basically just like categorical. Ordinal is you can order those data. Let's do a review problems. I'll give you 1 minute to take a look at the problems and we'll come back. Okay, so first one, number of bicycles sold in 1 year by a large sporting goods store. Is this categorical or quantitative? So it's number of bicycles. It's going to be quantitative. Second one, different colors of baseball caps. For different colors, it's in different categories. So categorical. Times it takes to cut a lawn. So times is measured in numbers. So quantitative, such as 20 minutes, 30 minutes, measured in numbers. Okay, we also talk about how do you put the quantitative variables into discrete or continuous. Okay. For the discrete, it means it can have whole number, while continuous means it may have decimal numbers. So first one, number of DVDs rented each day. Number of DVDs. It has to be whole number, so it's be discrete. Water temperatures of 6 swimming pools in Pittsburgh on a given day. Temperatures can have decimal, so it's going to be continuous. It can be continuous between any 2 integers. We also mentioned about 4 levels of measurements. Okay, so I'll give you 30 seconds to try to do these problems. We'll come back real quick. All right. So number of pages in the City of Cleveland telephone book. Pages should be numbers, okay, in numerical numbers. If number of pages equals 0, does that mean the telephone book doesn't have a page? Yes. So this will be a ratio, meaningful 0. Ratings of a local school. Ratings, that's usually an easy one to see. Ratings is going to be ordinal, because you can order those from the poor to excellent. Marital status. Marital status has to be in different categories, different names, so it's be nominal. Rankings of tennis players. Rankings, again, that's going to be ordinal, because you can rank those. Alright, so that's what we did last time, and in this lecture today we're going to talk about different kinds of aspects of the misuse and use of statistics. Okay. So the following 3 examples are the properly used stats, such as in education, science, and government. You can use statistical analysis properly to do the study. But also, statistics can be misleading. Very famous phrase here, there are 3 kinds of lines: line, stem lines, and statistics. Okay, let's look at the next example. I'll give you 20 seconds to review the problems, okay, and see what you see as misused. All right, we're back. Of course, the firm has 8 people who earn between $200 and $240 per week, and owner itself pays $800 per week, and he reports average wage is $280. So 280 is misleading, all right? Misleading because apparently this is higher than what most of the employees earn. Okay, so this is a misleading statistics. Different graphs and the use of graphs can be misleading. It depends on how you manipulate the scales and titles. So we need to pay attention when we do the graphs. Also, misuse of stats can come from bad samples, such as voluntary response sample. Voluntary response sample. I think we've talked about last time. If you voluntarily responded to a certain survey, that can be considered to be biased. Biased. All right. Very small sample size. The one we had before over here, this one, it has 8 people in total, and they reported average to be 280. Again, that's because only 8 people, and they use the average, which is misleading. The next thing we want to talk about is correlation and causality. Correlation. Okay, correlation means A causes A and B are correlated, they are related. Correlation. While causality means A causes B or B causes A. Okay, so correlation is sort of two-way. While causality means only one way. Misleading percentage is also a misuse of stats. 100. Just remember, 100% equals all. Some of the survey questions can be loaded. Okay. Loaded questions or intentionally worded questions can be misleading, such as the following example. Subjects were asked if they agree with the following statements. Too little money is being spent on welfare, or too little money is being spent on assistance to the poor. The percentage of agreeing to these statements is 19% versus 63%. So you can see being loaded. One is talking about welfare, and one is talking about assistance to the poor. So more people tend to agree with the second statement because the statement itself is loaded. Okay, if someone refuses to respond to a survey question, then you're having non-response. That's going to affect the legitimacy of the data. That's also going to affect the result of the study. Subjects may drop out for reasons unrelated to the study. That's missing data, which can also affect the effectiveness of the study. Too precise number can be cautious. Okay, you need to be cautious of those numbers because a lot of times it may be an estimate, but cannot be accurate. Self-interest study. Okay, a lot of times it's related to monetary gain. So these results we need to be cautious about those. Okay, so next we're going to talk about a discussion, okay, of the following statement. I'll give you 1 minute to read the first question 1 and give me your think about your comment. Okay, so this one talks about data published in USA Today were used to show that there is a correlation between the number of times songs are played and the number of times the songs are purchased. Conclusion: increase in the numbers of songs are played causes sales to increase. So what happens is in the first statement, they were talking about a correlation. These two, the number of times songs are played and number of times songs are purchased, these are correlated. correlated, which means these two are related. It doesn't imply that the time songs are played would increase, would cause the sales to increase. So we should comment here saying that correlation does not imply causality. Which is what the conclusion says. That's wrong. Okay, next. Give you 30 seconds to read. Okay, so it says a dental rinse can reduce the plaque on teeth by 300%. But that's impossible, right? Because all equals to 100%. 100% is the highest percentage you can do. So all equals 100%. 300 is impossible unless you do 3 times of all. Okay. Next one, headline of this amount of people in America. Okay, this is precise number. The precise number can only be an estimate, not going to be accurate. Alrighty, so we're going to talk about next how do we collect the data. Okay. First of all, data can be collected in 2 sources. One is called an observational study, one is called experiments. So observational study is easy to understand. Basically, you just observe and measure what happens. Okay, this is a lot of times happened in survey because you just observe survey. So observational study. Next example, a study which explores the correlation between smoking and lung cancer. Would collect observations of both smokers and non-smokers. There's no manipulation of those data. They just observe and write down. Experiments. Experiments, we know that we can manipulate the variables, right? And try to see what's the effect. This is typically done in a lot of social science or natural sciences. Physics, chemistry, biology, medical research, they use this experiments a lot. So I'll give you guys take a look at the following example here. It's talking about the little mouse. So after 18 months, the brain tumor rate for the mice exposed to cell phone radiation was twice as high as the brain tumor rate for the unexposed mice. So that's one experiment because they have manipulated the number of hours per day to the same microwave, right? So observational study, based on when it's conducted, it can be further classified into cross-sectional study, retrospective study, or called the prospective study. Okay, as for the first one, the cross-sectional study means it is collected at one point in time. Retrospective study, it means going back in time, the data are collected. While the prospective study, data are collected in the future, such as that smoker versus non-smokers. In the future, they are checking to see how they behave. Okay, let's stop at here. Yeah, and let's stop at here and we'll come back and to do some examples of this cross-sectional versus retrospective versus prospective study. Okay, thank you.